Okay, so now that we know how to assign materials to points, let's turn them into light sources, because that's usually a very nice effect. I remember a couple of years ago there was a student short film called Hybrids that used a shot like that. I'm sure there are other examples for it. But this is just simply a relatively easy way to create a really nice shot. I will show you three techniques. Not all of them are efficient. The most efficient one will be the last one, but I nonetheless want to make you aware what options you have. So the first way of doing it is just using materials directly. We may just make the material on the points glow, and this way they illuminate the surroundings. The second one is turning the geometry of the points into or turning the points into geometry first and take this as a geometry light. And the most efficient way from the standpoint of speed and quality is to actually instance a light source on the position of every point, and then the calculation will be with actual light sources, which is usually the most efficient and the most noise free. Okay, so let's start with the first option, which is I think the easiest, and that is we just take the materials on our points. This is a render of what I have right now. And the points have currently a material assigned via the material parameter here. And in this is the simple material that is set to white, and this is what you saw here. Now what we can do is we can just go down to the emission part and just make this, and just to make sure that we see what it's doing, let's turn this into yellow with the emission intensity already set to 1. Now if I render this, you will see that it certainly starts to be bright, but be very careful when it comes to glowing. So first of all, what we currently see is a mixture of the emission and the light reaction that still happens with the base color. And you can see there is some kind of weirdness going on. It's kind of bright yellow and bright white at the same time. I would always recommend, if you use emission, to turn everything else off. So for example, we can take the base color and just turn it to 0, and our reflectivity or metallic, if we have, I would set to 0 as well, because this way it feels way more like an actual light source instead of being half source, half receiving light. And what you can also see is, okay, it's bright now, but it doesn't feel like it's glowing. And this is actually the most important step now. To make this a bit more visible, I take my environment light that's currently illuminating the scene and dial it down a little bit. And we have something like this. And you can see it's bright. So it's also not influenced by the light source currently, but it's not really illuminating the scene. And who of you knows a little bit about rendering will instantly know what to do here. We have to turn on indirect lighting, or how it's called in Mantra, the diffuse limits. So basically it's global illumination, and you turn it on by setting the diffuse limit to something higher than 0. And what that basically means is that the brightness of a material is influencing other materials. So it's indirect lighting. I wouldn't go usually higher than 1, but in this case, let's go 2, because it's our main light source. And you can see not much has changed overall, maybe a little bit. And the reason is that basically our yellow color is not bright enough. The easiest way to fix that is just in the material to make sure that the intensity is higher than 1. Basically, if you take the intensity, you can consider this as the brightness multiplier of a light source. So let's increase that to 10, let's say. And instantly you can see something is happening. And of course, the brighter your emission, the more reaction you will see. And now you can see, let's go even further, just to prove my point. The higher you go now, the more will the surroundings be actually illuminated by those points. And as you can see, this is not just reflection, this is also brightening things up. So let me save this picture, go back to 1 so that we have a comparison. And now you can see this is clearly now a light source that is illuminating our scene. Now the problem with this approach is that it tends to be really slow in rendering and also relatively noisy. So if I just keep the settings I had before, you can see there's a lot of noise, and this is really normal for GI basically. And this is why I not necessarily recommend this approach. This makes sense though when you have, different colors on your light geometry. then this could make sense potentially. So for example, if your light source is supposed to have different colors in different areas of the surface, then this approach can make sense and you can't get around it. But in our case here, where we just want, one colored lights, there are better ways. Of course, the way to fix that would be to increase the sampling in our render settings, but I don't want to go deeper into this. I just want to show you the concept. The second way you can do this is using it as a light source, but as a geometry light. So we, for now, turn off the emission on our point material by, for example, just turning the emission to 0 and then bringing back our base color. And before we move on, make sure that now that we don't need it anymore, that your diffuse limit is back to 0. Otherwise, it will slow down everything we do from now on. We're back to this. Okay, so we turned our function off. And what we can do now is we create a new light. And this time we use geometry. So any geometry we can turn into a light. And what we can do is, weirdly enough, you will find that under area light options. And here you will find geometry object. And here we just choose our point geometry. And let's see if that works. And it doesn't work because we actually don't have geometry. We only have points. And points by themselves actually have no surface. So how do we solve this? For this to work, we actually have to turn our points into geometry ourselves. And of course, we know how to do that. We just use a copy to points. So what I do is I take a sphere, turn it into polygons, so that it's actually normal polygon geometry, and then use a copy to points to copy it on our point that we used. And since there is a p-scale on it, it just becomes the geometry we saw at render time now in real. And if I render this now again, this should work because now the geometry light actually has geometry that it can work with. We still have a problem though, and that is this. So we certainly can see that something happened, but it still looks a bit odd. And that is because now the spheres are on top of the light source. So the funny thing here is you have to actually turn those point geometries off, and then you can see that there is actually light reaction, for example, down here, but you don't see the light source itself anymore, which is a bit weird. And therefore, what you have to do is you have to tell the light to be actually visible in the render, and you can do this with the render light geometry button up here. So you can see a lot of work, but nonetheless, as you can see, it does actually do something. But what you can see, just like before, it's relatively noisy. The best approach is to say, okay, we don't use any geometry, we use lights. So get rid of the geometry light. And because we will use it later, let's make sure that we also get rid of the spheres that we created so that we only left with actual points. And we will use those points to copy light to it. And first let's create this light, and that will be of course a point light like this. So this is actually already what we need. And now we use a node that is very helpful for this, called an instance node. Now the way this node works is a bit weird at first. You have to actually put inside of the node the points you want to copy something to, and from the outside under instance you can define what object should be copied to those points. So we want the object that should be copied to be our light. It's called highlight here, or H light. Let's call this P light. Yeah, so that's easier to remember. And you can see something happened. Something comes out of this instant node in form of a sphere, weirdly enough. But the thing is, currently there is an add node in here with a point at the center, and we will replace this with the points we want, and we get the points we want via an object merge. So again, the weird thing about this node is that it takes points inside of it on its own sub level, and then applies the object that we define on the object level. So let's find the points. They're under points, of course, and we just take the render node. That's fine. All we need is points. And if we go back up, there are two ways of instance something. By the way, you don't have to instance light only with this. you can instance whatever you want. So if you want to have an instance of a complex object, instead of using a copy to points node, for example, you could use this node, which is even a bit more efficient. But let's not talk about this in this video. In this case, we want to instance lights, and you can use full point instancing and fast point instancing. And depending on what you want to do, fast point instancing could be totally fine. For example, for geometry, something we don't need in this case, but nonetheless, if you want to instance complex geometry like a light, then you have to use full point instancing. Now you can see that it understands that the points that we are merged inside should be used to copy this object onto them. And this is what we see right now. So this is very promising. And now if I press render, first of all, what you can see, it's super bright. And the reason is simply that we have so many lights now. I think it was 300 points that come out of our points geometry. And each of them have a relatively high exposure. So let's make sure we dial this down, because otherwise it will simply be way too bright for us. So maybe even further than that. And now you can see we're getting somewhere. And the cool thing about this, if we render this not as a progressive rendering, but as a final rendering with the same sampling that we had before, it becomes instantly a bit slower because it's so many lights. But what you will see is that we have almost no noise, because now the light sources are actually light sources. So we could even lower the sampling for this because it doesn't create noise. Now, of course, the problem we see right now is, again, that we see the light reaction. So that certainly works, but we don't see the light source itself. And a point light doesn't allow you to render the light geometry because it doesn't really have any kind of area that it could show. So make sure that you actually turn back on the geometry that you actually use, the points, but then you have a problem. And that is that you can see that all of a sudden the lights turn off. The reason for that is that the spheres all of a sudden cover the light sources. So what can you do about this? Well, first of all, let's make sure that our spheres are looking like they are emitting light. So let's turn on our emission again, this time to white, and turn then our diffuse color off, including reflection and metallic. And then also make sure that our spheres don't cover our lights. And you can do this under points, that under render, our geometry will only be visible but will not influence the lighting. For example, it will not create shadows or covering lights. We can do this under render visibility by turning this visible only to primary rays, and primary rays, of course, being only the stuff that we see. And if we start this now again, you can now see we have geometry that is bright and looks like it illuminates our scene, but it doesn't do that directly. It does it because we instanced point lights on the same position as those spheres. Now, one thing you have to be aware of when you instance lights is when you look at the render, there is actually a light in the center that is glowing. You can also see that in the viewport. There it is, because the instance node will instance the point light, but the point light is still there. So what you can end up with is that there's one light in the middle of your scene that you just forgot about. And this happens to me all the time. So what you need to do to fix this is, in your Mantra node, you can make sure that you do not just render all the lights that are turned on, but you use the force lights to explicitly only render the, and this is interesting, the instance light, which you can't see here. So as far as I remember, there are ways to make it visible in this list. I forgot how, but it doesn't matter. You can just type in the name of the node of the instance, the instance node, and that would be instance 1. And I just put this into force lights. And as soon as I do this and I render this, you will see that it will still render the instances as lights, but since the point light itself is not in our list anymore, the little glowing point in the middle is gone. Another thing in this regard is when you use force lights, and you should be aware of this concept because you should do the same for objects. This candidate light star is actually a workflow I would definitely not recommend doing. Always explicitly choose the geometry you want to render. But when you choose all the geometry and leave the instance node out because you're rightly assuming, well, this is a light, it doesn't need to be in the list of objects I want to render, then you will see that you don't see any lights. So that's another thing. If you use the force objects, which you should in my opinion, then don't forget to add the instance node, otherwise it will not work. And here you can see how this would be built up. Ideally, you have the instance in your force objects and the instance as the light, so that the point light that is actually copied will not be rendered itself. I agree, it's a lot of work. You have to, remember a lot of steps and consider a lot of steps, but it's the most efficient because you can see it's a technique with the least noise. And this is why I would always prefer to go this way, because a light source will always be more efficient than any kind of surface calculation, either with geometry lights or indirect illumination. Both techniques tend to be very noisy and slow. And this technique is a bit more work, but way more efficient. Okay, so like I said, it's a very, very cool technique to create really interesting renders. And yeah, let's see what you can come up with. So thanks very much and see you later. Cheers.